Hey, this is Mr. Coker with Geometry Lesson 1-5, Dilations centered around the origin. So, dilations, what we're talking about is either increasing or decreasing the size of an object on a coordinate plane. So, we're going to use this graph as an example, or this triangle on the graph as an example. So, you can see our triangle, we've got our three sides, and I labeled the points A, B, and C. And here are the points for each one, the ordered pair for each of the 3 points. First thing I want to mention, scale factor. As you can see, if we have a scale factor greater than 1, it is an enlargement, it's getting bigger. And if it's less than 1, it's getting smaller, so a reduction. Now doing this work is really simple. So we're going to take whatever the scale factor is, and it'll be a number, and we multiply that number by each of the numbers in each of the ordered pairs. So I'm going to start by doing a scale factor, SF, obviously for scale factor, of 2. So we're going to make a new triangle with a scale factor of 2. So you can see 2 is bigger than 1, so it's an enlargement. Our triangle should get bigger this time. So I'm going to start with point A. We have 1, 1. Well, 1 times 2, of course, is 2. So 1 times 2 is 2. 1 times 1 is 2. Our new point is 2, 2. Our next point, point B, 2, -1. Well, 2 times 2 is 4, -1 times 2 is -2, and our new point, 4, -2. And finally, point C, -1, -1. Well, just like 1 times 1 is 2, just like 1 times 2 is 2, I meant to say, -1 times 2 is -2. So, those are our new points, our new ordered pairs, and we're going to plot them. To begin with, we'll start with 2, 2. I'm going to erase the original points. We don't really need them anymore. We have them here. So 1, 1, now we're going to go to 2, 2. We're going to, instead of 2, -1, we're going to do 4, -2. And instead of -1, -1, we're going to do -2, -2. Going to make the line. And you can see this is a similar triangle. Similar triangle meaning it's the same shape. It's a different size. This triangle, of course, is bigger because it's an enlargement. Each point is further away from the origin. It's actually twice as far because our scale factor was 2. We multiplied by 2. So now we're going to do and of course it's bigger. Now let's do a reduction so you can see the difference. I'm going to leave that scale factor of 2 up. So I'm going to write the new one down here. I'm just going to use the points that we have. So now we'll do a scale factor of 1/2. I like to keep the numbers simple for a demonstration. So 1, 1 is going to become, well, what's 1 times 1/2? Well, anything times 1 is itself. So we're going to have 1/2 and 1/2. I'm going to write it as a decimal of 0.5. 1/2 and 0.5 having the same value, of course. One's a fraction in decimal, and one's decimal, but they're the same number. So now let's go to B. 2 and -1. 2 times 1/2. Well, what's 1/2 of 2? Of course, it's 1. And then -1 times 1/2 is -1/2. I'll put it again as -0.5. And then C, which I'll have to put on this side, we have -1, -1. Of course, this will be the opposite of 1 and 1. So instead of 0.5 and 0.5 or 1/2 and 1/2, we'll have -1/2 and -1/2. So I'm going to take those numbers, I'm going to plot them on our coordinate plane. First, 1/2 and 1/2. I'm going to look in between 0 and 1, halfway between. I'm kind of estimating here, but I'm going to make a point (1/2, 1/2). Now I have 1, -1/2. I go to 1, down to -1/2. And then we have -1/2, -1/2. Going to connect our 3 points. And you can see, hopefully, we have another similar triangle. Only this one's much smaller. Look at the huge difference between the scale factor of 2 triangle and the scale factor of 1/2. Huge difference. Because one's 4 times as big as the other. It's really something. So this is dilations centered around the origin. It's really simple. Just make sure that you do your multiplication correctly, and it'll be pretty simple. So thanks for watching.